How's it going, y'all? So today we're going to talk about error analysis with Slope-Intercept form. I know that Slope-Intercept form is nothing new, but remember, if you recall back when we did our unit a couple months ago and then we gave the assessment, I told you all that there are a lot of common mistakes that were being made, and I wanted to make sure that we addressed them and worked with them before I started moving on a little bit. Slope-Intercept form is literally the entire first month and a half of what you're going to be doing in advanced math next year. And so I really want you to have a strong base of understanding it and using it. So what I decided to do was I looked at your common mistakes that you made when we took this test back in like February. And so I kind of went and divided it into, you essentially have three different types of errors that you can make. So the three types are these ones. So the first one is like a slope error. And so typically things that I've seen students do is they're switching the change in y and change in x. So usually I'll see x over y rather than y over x. Sometimes they're using a single point to write the slope. Basically, whatever work that they're doing, it's involved with they're not calculating the slope correctly. Now, you did slope review the entire week before this. So my hope is that you've recalled that information well enough that you can catch when those slope errors are being made. So the next one's called a Y-intercept error. And so remember, y equals mx plus b is slope-intercept form. And you know that because the past couple of lessons that you've had this week have been reviewing that. But so some students I noticed when you guys took the test was that you calculated the slope beautifully, but then when it came to your y-intercept, instead, you really struggled with finding the y-intercept on a graph or a table. And you truly just showed that you didn't understand what it truly means, like what the y-intercept means in terms of either the equation or in terms of the situation. And then the last type of error is just a general equation error. And so what I was also seeing was just some of you just kind of randomly threw information into the equation and kind of overlooked what each part of the equation represented. So including the y, m, x, and b, and what each part represented. So generally these are the three different types of errors that people can make and that I did see happen when you guys took this test back in February. So what I wanted to do was show you like what those errors actually look like. So first up, we'll talk about ones that are slope errors. So here's one question that I have right off the bat, or one problem that I have off the bat. So slope on a graph. So notice that this student saw that you have your 2 points, and then what they did is they found their change in y and their change in x. But notice that when they put it into slope, they put their change in x and then their change in y, their horizontal change over their vertical change. It is key to remember that it is always supposed to be, I gotta find pen here, okay? It is always supposed to be change in y over change in x, your vertical change over your horizontal change. So the slope of this line is actually -1 over 2, or -1/2. So for each jump between 2 points, it averages to be about 1/2, okay? So there's one example of why a student could make that error, okay? Another one is here. So I even said like you can make a slope error with a table. And so some cases what I was seeing happen is that some students were just looking at a point and saying, okay, my change in y, my y is 4, my x is 1, so my slope is 4 over 1. Instead, you need to look at what is your vertical change. To go from 4 to 16 is adding 12. And I'm writing with a laptop, so forgive me if my numbers don't turn out wonderful. Okay, so your change in y there is 12. Your vertical change is 12. And then you want to look at what your horizontal change or your x changes. And to go from 1 to 5, I'm adding 4. Now notice that when I make it into the fraction, I'm not putting in the pluses, and that's just because we live in a society where we don't need to notify when something is positive. We know something is positive when we don't see a negative sign in front of it. Now, you are all 7th graders, and I know you're capable of doing this. 12/4 can be simplified, and either you can type it into the calculator and push simplify, or you know it's 12 divided by 4, which is the same thing as 3, okay? So those are 2 different common things that I saw when it came to slope error. So the next one that we have is your Y-intercept error. Okay, so here is one of the first examples that I was seeing quite a bit. So this student, this was a common thing that I noticed, what was happening is that students were finding your slope, but then you were taking either the y, the change in the y, or you were just using that coordinate, and you're just saying that it's 1. You have to remember that visually on a graph, the y-intercept is when the line intercepts the y-axis. So your line is here in blue. It intercepts the y-axis right here. So you need to find the value of y that is at that intercept graphically. So here, there's your 0. I noticed that it's 2, positive 2 in that direction. So actually your y-intercept in this is 2, okay? And then the other example that I have is in a table. What I was noticing was that a lot of you were diving into trying to use a pattern and a thinking strategy. You were using it like working backwards on a table, and a lot of you just did that even though the y-intercept is like glaringly right there for you in the face. A lot of you are used to x equals 0 being right up here. Right? Graphically on this graph, right? The y-intercept is when x is 0. There's no horizontal movement. So you need to find when x is 0. In the wonderful world that you've been living in, x has always been 0. That's always been first. But it's not going to be the case with these situations all the time. So you need to use your observing skills. So in this case, what I was seeing is a lot of you were either saying like, hey, it's that first number for y, that's my y-intercept, because you weren't observing that that x had to be 0. Instead, you were just choosing the top value. Whereas in this case, it's right here in a table. X equals 0. So graphically, x is 0, y would be 2. And these actually almost kind of match, don't they? But they don't. So your y-intercept in this case is actually 2. It's not 0, 2, it's 2, because what is the y value when that line crosses the y-axis? And when y-axis means x is 0, like there's no horizontal movement. It's all on that vertical piece, all that vertical distance, okay? So then our last one that I had for you was your equation error. And what I noticed was that a lot of you were just really struggling with putting the information that you were given in either a graph, a table, or even a word problem. You were really struggling with how do I put that into an equation. So here is the first example that I have for you, okay? And then the vice versa too of graphing it, which is, it's funny to think about that because a lot of math teachers, like even me, even when I'm teaching 6th graders, like I graph just looking at the two values given to me on a equation. But anyway, so the directions for this problem were to graph the equation y equals negative 2x plus 4. A lot of you, I know, do just make a table and you start putting in like x values. So this is not the graph. This is not the correct line represented by that equation, by the way. Oh gosh, that table looks terrible, right? So a lot of you would just automatically make a table, and then maybe you would choose x values of like 0, 1, 2, or whatever, right? You would just choose whatever values you wanted. You would use that equation to find your y. So 0 times negative 2 plus 4, 1 times negative 2 plus 4, and you put those there, and then you graph those points and you're good. Remember that you can also use what the information is in the equation. That's your y-intercept, 4. And you know where 4 is on the graph. See, what happened here is that this student saw the negative 2, so they went negative 2, and then they saw the 4. And so what a lot of people will do is they just look for those values, and they put dots on those values, and they just use that. And that completely shows that like you don't understand what to do when it comes to the equation at all. So that's why I'm showing this to you. Okay, so your y-intercept is 4. Do you know where 4 is on the y-axis? It's right here, right? And then knowing that your slope here is -2, okay, and I know some of you still are like, Miss Wolf, that's not a fraction. You know what? The beautiful thing about any type of rational number is we can turn it into a fraction. So if you think about -2, what is it as a fraction? Literally any integer you're given, pop a 1 underneath it. Because you know that to make a -2, you need to do something divided by something to get -2. You could do -4 over +2 if you wanted to. Doesn't even matter. As long as it equals -2, you're golden. So it's -2 over 1. Now, what I'm seeing is that some of you also are just looking for the points -2 and 1. No. Remember, this is your vertical change and your horizontal change. So my horizontal change is +1, +1. Your vertical change is -2. So remember, that's down 2. So then you have your 2 points, and this is going to be a very squiggly line because I'm using a laptop, but that's what your line would look like. Okay? So that's one mistake that students have been making when it comes to using the equation and thinking about how to use it to graph it. So then the last one that I have is thinking about labeling things off of your equation. And the funny thing is like there was a test question that I gave you, and it was actually considered, in my opinion, a level 1 question. Like it literally was identify this and it's right in front of your face. But the funny thing is a lot of you looked at me like I was insane. Like I don't know what to do. So like this question here says, what's the slope of the line represented by y equals 2/3 x plus 4? And the crazy thing is, and I think actually the problem that you were given on your test was y equals x plus 4. And all of you said there's no slope. There was. You have to remember that slope is always in front of x. So in this case, it's 2/3. If it was just x, there is an invisible coefficient, which we talked about back in February. Invisible coefficient. What number multiplied by anything doesn't change its identity? 1. 1 can be assumed when you see a value and it doesn't change, right? So like, if it was just x plus 4, your slope is 1. But you don't go home and tell people you're 1 times 13 or you're 1 times 12, because people look at you like, yeah, that's the same thing as 12. Yeah, that's the same thing as 13. So that's why you don't always see 1 multiplied by a number written out, unless I'm asking you to identify a property, because really it's like an assumed, we know that it's an identity. Okay, so just kind of recall those pieces to you. I think, yep, that's all I have for you for slides. So these are generally the 3 types of errors. So replay this video if you need to, but remember, we have slope error, we have y-intercept error, and then we have equation error. So just kind of recall, like kind of connect yourself with all these different types of errors and think about, have you made these mistakes in the past? What was the misconception you had? And think about how are you going to undo that misconception? Because our brains fire off when we make a mistake, and our brain knows we made a mistake, but you don't always know that your brain's making those connections. And so what you need to do is make sure that you're trying to cognitively like be aware of making those connections, of fixing that mistake, so that you have a better and solid understanding of slope-intercept form. Okay?